Okay, then. So moving on, we're looking now at integration with parametric equations. So chapter 8 introduced you to parametric equations. And across the slides, I think parametric equations looks easier than it is in exam papers. In exam papers, parametric equations can get a bit tricky. And that's because it links with differentiation. And you saw a little bit of that. You saw this idea here. But it also links with integration. So if we have where x is a function of t and y is a function of t, we can find the area under y with respect to x, and we can do this indirectly. We don't have to turn y into some function of x. We can do that using these pieces as they are. So what's the secret? Well, the secret is that we're going to talk about integrating y, and then we're going to multiply it by dx dt. You can find this by differentiation. And then we're going to integrate the whole thing with respect to t. Now, if I I'll draw it again underneath. If I write it like this, you might be able to see how actually they're the same thing. But the idea is we can do this indirectly, because this is about integrating what y is with respect to x, where y is in terms of x. So this talks about there not being any t, whereas we have x and y in terms of t. So to reflect that, this is the way that we can go about it. Okay, so you need to spend a little bit of time really making sure that you can recall and use this one correctly, but it's all about introducing this extra piece here so that these multiply. The way I always think of it is the things are in terms of t, so you have a dt on the end, so you have y with dt, and then I think about what do you need to put in there so that it looks the same as it normally does. But that does take a bit of practice. Let's just do a quick example. So let's get rid of those annotations. Okay, so we'll just use that. We'll use that one there in a moment. So determine the area between the curve with parametric equations, this and this. So we've got things in terms of t. The x-axis, so these are our limits, okay? That's what all of this is about. So first thing we could do is find out this new part here. So dx dt. And the way to do that is to use this one here. So that's going to be, differentiate the t, that's going to be 2t. Okay, so finding dx dt. What else do we need to do? Well, because we're integrating with respect to t, our limits are going to have to be in terms of t as well. So here, these limits, they're in terms of x. So how do you turn the x limits into the t limits? You need to use the equation that has x and t in it, which is this one here. So 0 would go to 0. And what was the other one? 3 should go to 9. So we changed the limits as well. So we're getting all of the parts ready to integrate. When x equals 3, oh, sorry, I got that one the wrong way around. That should be root 3. Okay, now we've got all of that, we can start trying to put it together. So we're integrating y. Well, that is t plus 1. Okay, so that's what we're integrating with respect to t. The limits are going to be root 3 and 0. So that's the limits done. That's this y piece here. dt, that's a notation thing, okay? So it says you're integrating t's. So if you have t's and you want to integrate, that needs to be the same letter. But you need this part here as well, dx dt, and that's 2t. So we've got this sort of situation here. If we expand out this bracket, so 2t multiplied by both of these things, we get all of this one here. And now this looks like a regular sort of integration. Remember, this means you're integrating with respect to t. So t squared, t cubed, bring down the new power, etc. So like this, and for the t squared. And then finally, actually use the limits for t. So in other words, you're indirectly integrating the function y with respect to x. And you're doing it indirectly because things are in terms of t. So the trick is to use this part here, and we've seen why it works because of this cancellation. But in order to do this, you must make sure all of your limits are in terms of t. Your y is already in terms of t, and you need this extra piece dx dt, and you have to do some differentiation for that as well. Let's have a go at another one. So x is in terms of t, y is in terms of t. T has to be greater than or equal to 0. That might be important. Find the exact area of the region R found by the x-axis, and the x-axis is just telling you so you don't have to split it. It's just saying it's like a normal regular integration. The line x equals 0 and x equals 2. So dx dt, easiest way to do this. No need to do the product rule, just expand it out. So t plus t squared. Differentiate that one. Okay. X and x, they need to be in terms of t because we are going to be doing this. Okay, so we need to change these into terms of t. And the way to do that is put this x in as a 0 and work through for this one and for this one. Now, interestingly, this one you get 0 equals t1 plus t, and that's kind of a roadblock. So what you do is you look back over the question, you look over the diagram, and you see if anything can help you out. And actually, it was this part here. So do you remember we said this might be important? T has to be at least 0, helps you disqualify that value, and it lets you actually make progress. Otherwise, you wouldn't have been able to do that. And for this one here, the same thing happens. It turns into a quadratic, and one of the values gets disqualified. So you know that it must be 0 and 1. So that's why even the things that sort of don't look important, it's worth just having a think. Why are they there? Everything has been put in there for a reason. Okay, so you've got your t limits, you've got your dx dt. What would we do next? We'd put our y value there. So we're integrating between 1 and 0. Those are the t limits, 1 and 0. Y is 1 over 1 plus t. Don't forget, it has to be multiplied by dx dt. dx dt was 1 plus 2t. Okay, and then that's all integrated with respect to t. So here you can sort of put that part on the numerator. That's what's going to happen. Okay, so that's what I mean. We're at this line, this part over here. What we've got though is we've got a top-heavy algebraic fraction. So we need to be able to recognize that. The power of t is 1. The power of t in the denominator is 1. This is called a top-heavy fraction. Okay, so if you do long division, you'll get this one here. And then we're in a position to integrate. So quite tricky there that you're meant to spot that it's a top-heavy algebraic fraction, but this is what happens at this point, is all of the maths starts getting put together. Okay, pause the video here then and have a go. You've got some sort of clues here to help you out. And I'll just remind you that we've got to integrate, let's call it like T2, T1 in this format here, if we're integrating parametrically. So it looks like x is 0 here. So that's going to be used to find, that t is 2. And there is a relationship between x, y, and t for any given point. Okay, so that's what's going on for this first part here. Find the x coordinate at b. Well, b, it looks like y is 0. So what will probably happen is y will be 0, and this will give you t, and then t will give you x. Remember we said for parametric, it's about bouncing between the 3 letters and problem solving. So it's 1, 0, which matches up with the diagram. So you can be pretty confident when you have that answer. Use the integration. That's what we've talked about. And we get this exact answer here, which is 15 over 2 log 2. 2 log 2, you could write that as natural log 4 if you prefer, minus 2 or equivalent. Okay. They're changing the limits from x to t here at the top. Okay. And then working through the rest of this one here. So this is what a question might look like. So parametric questions are often not just parametric on their own. It's often maybe some coordinates, like you saw in chapter 8, and integration, or some coordinates and differentiation, or maybe even the whole lot together. And a quick note about parametric integration is that if you have one of the old books, you might be missing this this set of questions here from your book. But it is in the course, so you should make sure that you practice this and that you're able to do these questions.